Good morning, ladies and gentlemen. My name is Somboon. Today I would like to present in the topic of development of methodologies based on the Belousov-Zhabotinsky reaction for ethanol determination. The Belousov-Zhabotinsky reaction is the oxidation of an organic substrate, for example malonic acid, by bromate in sulfuric acid solution with a metal catalyst complex, for example, ferroin. Two phenomena can be observed in this reaction. The first one is called chemical wave, as shown in this movie. The second one is an alternate color change from red to blue corresponding to the oxidized and reduced form of ferroin catalyst. As shown in this picture. Recently, there is some research work about applying wave for determination ethanol in alcoholic drinks. The method is processed via the calibration plot between wave velocity and ethanol standard concentration. For oscillation, Sansuk and co-worker successfully used oscillation, temporal oscillation and liquid-liquid extraction to determine ethanol in gas alcohol sample. And also based on oscillation, the colorimetric oscillating signals COS obtained by data processing can be successfully used for determining ethanol in alcoholic drinks. Although two phenomena in the BC reaction can successfully done, we would like to present in this work the investigation, the advantage, disadvantage, limitation of both methods compared to the gas chromatography, which is high-class technique. Thus, the objective in this work is to compare the method based on the colorimetric oscillating signals and propagating wave in the ferroin catalytic BC reaction for ethanol determination, and to analyze the limitation, advantage, disadvantage of both methods compared to the GC techniques. Experimental method. To generate propagating wave, we need to prepare the catalyst gel first by mixing ferroin, sulfuric acid and water first, and then transfer to water glass. Then the mixture was transferred to petri dish, then let it gelation. After that, the BC solution prepared by mixing sodium bromate, malonic acid, sodium bromide and sulfuric acid and also water was mixed and poured on the top of the catalyst gel. Then chemical wave occurs spontaneously. To study the effect of ethanol, we use the concentration of ethanol in the range 0.2 to 1% by volume ethanol standard solution add in the BC solution. The key parameter to access the ethanol concentration is wave velocity. I will describe the measurement of wave velocity. The first step, we need to generate BC wave in petri dish like this. Then we have measuring point. Distance between measuring point is 3 mm. We record time that wave propagate past the measuring point. Then when we obtain the data, we plot between propagating distance and time. So here, to get the slope of this graph, the slope is wave velocity. So when we study the effect of ethanol with various concentration of ethanol, we will get various concentration of various wave velocity. So we can get the calibration plot between wave velocity and ethanol concentration in linear manner. For colorimetric oscillating signals or COS, the mixture contains sodium bromate, sulfuric acid, malonic acid, water, sodium bromide, ferroin was mixed in a test tube, and then the dynamics of oscillation would be recorded by smartphone in video mode, and then we use the developed program in our group to make data processing to get the colorimetric oscillating signal like this. The key parameter in colorimetric oscillating signal is the oscillation period. With this, you can see this parameter T, which is the time interval between two oscillation peaks. The interval, this interval is called oscillation period. With this would be the key parameter for ethanol determination. Imagine that when we perturb or when we add the ethanol standard solution with different concentration range from 1 to 5% volume, the oscillation period will be changed. So we can construct the calibration curve plot between oscillation period and concentration of ethanol. Also, we use gas chromatography to access the ethanol concentration, so we need to construct calibration graph first. In this work, we use internal standard method. The internal standard is iso-propanol, and we make calibration of ethanol concentration range from 1 to 5% volume, and we prepare all the standard solution and all sample and inject to GC to obtain the data. Result and discussion. When we study the propagating wave, for example, show here the spatial temporal pattern of the BC wave under the addition of ethanol concentration 0.8. We will see the propagating wave in petitite, and we found that when we change the concentration of ethanol, the wave velocity, the value of wave velocity decreased with increasing of ethanol concentration as shown in this calibration graph. The calibration, the linear equation is shown here, where parameter is wave velocity and x parameter is ethanol concentration. This graph shows correlation coefficients 0.9929. This linear can be used for determine ethanol in sample. The sample we insert in this study is alcoholic sample, which is 3 band of alcoholic sample, which I will describe further. For colorimetric oscillating signal, when we get the alternate color change from red to blue corresponding to the oxidized form, reduced form of ferroin and oxidized form of ferroin, we use computer programming to get colorimetric oscillating signal shown here. We found that when we increase the concentration of ethanol, the oscillation period decrease in linear manner. The linear equation shown here. In this graph, we found that correlation coefficient is equal to 0.9989, and this would be the calibration for determine the ethanol concentration in sample. To describe while the wave velocity and oscillation period decrease with increasing ethanol concentration. We need to understand the mechanism to describe the oscillation first. The mechanism for describe the BC oscillation is presented by few Körös and Noyes. They consist three important process. Process A is the process to reduce amount of bromide, which is the bromide critical concentration depend on the concentration of bromate. And then the process would be switched to process B, which is autocatalytic reaction. And then is followed by process C, regeneration of bromide, and then back to A again. So you will see that in process B, the oxidation of catalyst occur. So you can see in this step, process B, in process B, the color of the solution can change to red, from red to blue, and then in process C would be the reduction of catalyst. So you can see the oxidized form of catalyst reduced to reduced form. So the color would be back to red again. This is the description that you can see the alternate change of red to blue color. So when we add ethanol can decrease the oscillation period. Imagine that the oscillation period is one cycle, A, B, C, back to A again. We have the literature reviewed about ethanol can react with bromate. So imagine when we increase the concentration of ethanol, the concentration of bromate decrease. Thus, the bromide critical concentration decrease. So in process A, it can occur faster. That means the oscillation period, the cycle of oscillation would be shorter. Thus, the oscillation period is decreased when we increase the concentration of ethanol. In case of propagating wave, Y, wave velocity decrease with increasing of ethanol concentration. For wave propagating, the wave velocity can be controlled by two important species, bromate and hydrogen ion form sulfuric acid. When we add ethanol, similarly to oscillation, ethanol would be react with bromate. So when bromate decrease, when the amount of bromate decrease because it's react with ethanol, velocity can decrease because this is the linear equation. Wave velocity depend on non-linear equation because wave velocity depend on bromate concentration. Imagine when bromate decrease, wave velocity can decrease. This is why we can find that wave velocity decrease with increasing ethanol concentration. We have tested the precision of two methods, both COS and BC wave. We found that from this result, we found that COS provide low percent ISD than BC wave, both intraday and interday precision. This indicates that COS method has higher reproducibility and precision than BC wave. When we use three methods COS, BC wave, and GC to determine the ethanol concentration in three types of alcoholic drink, beer, whiskey, and vodka sample. We found that COS and BC wave have low percentage error similar to GC. However, when we compare COS and BC wave, we found that the accuracy of BC wave method is lower than COS. You can see the BC wave provide higher percent error than the COS. However, the percentage error of the COS and BC wave are similar when compared to GC. Thus, this means that two methods of both COS and BC wave can be an alternative method to access the concentration of ethanol in alcoholic sample. The disadvantage or limitation of the present method compared to the GC method can be summarized here. The technical expert is required to observe the BC phenomena of both COS and BC wave. This is the limitation of this proposed method. The crucial step is the measurement of the propagating velocity in BC wave. This step is quite difficult, so it can be the disadvantage and limitation of the BC wave. And also COS require data processing step, which is not straightforward for most chemists. The work in this part, we have one co-worker. He worked about computer programming, so he can help us to process about the data to get the oscillating signals, which is this step we are not familiar with. However, both methods, BC wave and COS, provide an advantage over the GC technique in the sense of instrumental cost. Thus, I can conclude this work that the COS and propagating wave generate in the ferroin catalytic BC reaction are successfully applied to determine ethanol concentration in alcoholic drink. And second, the approach was straightforward and superior to the GC method in terms of cost and energy consumption. However, the approach requires specialists to get the accuracy of oscillation or wave velocity, which is critical for producing accurate findings. For acknowledgement, this research project is supported by Rajamagala University Technology Isan. Contact number here. Thank you for your attention.